All right, everybody, it's 5.4, part 2. We are integrating e to the x or e to the u. Yesterday we did derivatives of it. Now we're doing the reverse process. So we learned yesterday that if you take the derivative of e to the x with respect to x, it equals e to the x. So if you integrate it, what should you get? You should get e to the x plus some constant. Similarly, if you integrate e to the u du, you should get e to the u plus some constant. This is what you try to make every integral look like. And once you do, the answer is presented to you. So it's going to be a u substitution on every one. So we'll just start the first one here. Integral of e to the 3x plus 1 dx. So I'm going to do a u substitution. It is always going to be the exponent. Not always, I shouldn't say always, but when it's a single e in there, it will be the exponent. Derivative will be 3 du dx will be 3. So I can rewrite it as du over 3 is equal to dx. I've subbed out that as my u. Dx is now du over 3. This integral becomes integral e to the u du over 3. So I can pull out the 1/3, integrate e to the u du. Looking up here, we know is e to the u plus c. There you go. Oh, sorry. I guess I should put back in what u was. So it's 1/3 e to the 3x plus 1 plus c. And there you go. All right. Second one. Integral 5x e to the negative x squared. So what is my u going to be? I know it's going to be this exponent because the exponent has a power of 2, and if I take the derivative of that, I should get something to the power of 1, which is the x sitting there. So if I go u is equal to negative x squared, then du dx is going to be negative 2x. So I can solve for du, or sorry, for dx, and I'll get du over negative 2 is equal to x dx. And I guess I should have a dx over here. So now I've cleared out that is u. The x dx is du over negative 2. So the integral now becomes 5 e to the u du over negative 2. So I pull up negative 5 halves. I'm left with e to the u du, which is negative 5 halves. E to the u plus c. Plug back in my u, which was negative x squared. And there you go. All right. So, third example. E to the 1 over x squared dx. If you have an exponential e in this case, always, if you're not sure what to do, first try, always make u your exponent on the e. Just see what happens. If it doesn't work out, then you can try something else. So u is equal to 1 over x, which means that's the same as x to the minus 1. So du is minus x to the minus 2 dx, which is really just negative dx over x squared. I'm going to move that negative over, so I get negative du is equal to, and I'll rewrite it as 1 over x squared dx. there's my negative du. So the integral becomes e to the u times negative there, du. Negative can come out, and you can integrate e to the u, so you just get negative e to the u plus c. And what's my u? My u is 1 over x. So it's negative e to the 1 over x plus c. And there you go. All right. Oh, used up. Oh, okay. New document. So 1 second, people. There we go. Okay. So let's do one with trig. Yeah, I think they're 4. Doesn't matter. So integral sine x e to the cos x dx. Again, you have an e in there. If I sub out sine, the derivative of sine is cosine, but that's not going to clear things up. What you want is to make things look like the integrals I presented at the beginning. So our u we try as the exponent, which is cos x. The derivative of cosine is negative sine. So I'm going to move that negative over. Negative du is equal to sine x dx. Then the integral becomes negative e to the u du. So we get negative e to the u plus c is negative e to the cos x plus c. See, I know these can look complicated, but they actually, once you do the substitution, turn into fairly straightforward integrals. Okay, so let's do a definite integral. Integral from 0 to 1 of e to the x over 1 plus e to the x dx. All right. Now, what should you be? You have choices here. You can try the x, but if you do the x, well, let's just do it. Let's do the wrong stuff just to show you. If I go u is equal to x, I get du is equal to dx. So all that does is clear out that. And it does clear out that. So this integral, I'm going to erase this because it's not what you want to do. It would be e to the u over 1 plus e to the u du. That's the exact same integral. All right? So we're not going to do that. Doesn't help us. So the next thing we could try is usually when you have a numerator and a denominator, such as something like this, where the denominator is more complicated than the numerator, that should be your u. So we're going to try u is equal to 1 plus e to the x. So du, the 1 goes away, derivative of e to the x is e to the x dx. Well, that seems to have done something. This bit here is now du, and this bit is u. So now I've got the integral 1 over u du, and it's a definite integral. So we can change our variables here. So when x is 0, u will be 1 plus e to the 0. 1 plus e to the 0 is 2, because e to the 0 is 1. So u is equal to 2. That's our lower limit. And when x is 1, u will be 1 plus e to the x, or sorry, e to the 1, which is just e. I'm just going to leave it as 1 plus e. All right. What's the integral of 1 over u? That's the natural log of u. And I don't have to put plus c. Evaluated from 2 to 1 plus e. So just plug them in. Natural log 1 plus e minus natural log 2. I have no idea what that is. I would just leave it like that and walk away. All right, last one. Again, we'll do a definite integral. Oh, excuse me. You know what? I'm not even editing that out. Sorry, we are doing Renos, and it's kind of dusty here. All right. Integral -1 to 0 e to the x cosine e to the x dx. All right. What are you going to be? I don't think we want to make it cosine, because if we make it cosine, if I said u is equal to cos e to the x, my du derivative of cosine is negative sine e to the x times the inside derivative, which would be e to the x dx. That there's no sign anywhere. That's making things way more complicated. So we erase all that. The only other thing it can be, well, we could try it x. I don't know if that's not going to change anything. If I go u is equal to x, du is equal to dx. So I end up with integral e to the u cos e to the u du. Again, same as up here. It's the same integral. Okay? Just got u's instead of x's. So that's pointless. So the only other thing it can be is the e to the x. So we go u is equal to e to the x. So du, all right, so du is equal to e to the x dx. So that is du. This, oh my gosh. This is du, and that is u. So now I've got the integral cosine u du. And it's a definite, so we can evaluate this. When x equals 0, u is equal to 1, because we e is 0, which is 1. When x is equal to negative 1, u is equal to e to the negative 1, or 1 over e. So now our limits are 1 over e to 1. What's the integral of cosine? Well, that is sine of u evaluated from 1 over e to 1. So our answer is sine of 1 minus sine of 1 over e. I would leave it like that, but I think if you plug it in your calculator, you get approximately 4.82 or something like that. Remember, these are in rads. All right, we'll do one more, and then we're done. It's indefinite. So what if we have e to the 2x, 2 plus 1 over e to the x dx. So you could try u-subbing, but before you do anything, you should look. You have a single denominator like this. Go to each numerator. So this integral actually turns into e to the 2x over e to the x plus 2e to the x over e to the x plus 1 over e to the x. Obviously, the first term, you subtract the exponents because we're dividing. So that's 2x minus x, which is just x. E to the x's cancel out there, so you're left with 2. At the end here, it's e to the negative 1, or negative x, sorry, dx. You can treat each one of these as a separate integral. Integral of e, no, let's write them out. So this is the same as e dx plus integral of 2 dx plus integral e to the negative x dx. Obviously, the first integral is e to the x. The second one is just 2x. Third one, if you did a u sub, you're going to make it the exponent. Du equals negative dx. So that integral turns into e to the u negative du. Let's write it like that. The negative you can pull out. Integral of e to the u is e to the u. So we get negative e to the u. Looks really wrong, but I'll put back in my u, which is negative x. All right, and then you just tack on a plus c. And that is it. You are done. So you try to make every single one, map these two integrals here. And that's what you're trying to do with your u substitution. If it's one exponential function, natural exponential function, usually you're subbing out the exponent. If you start to have numerators and denominators, and the denominator is more complicated, make that your u and sub it out. Yeah, and I showed you a couple examples that don't work with our first u substitutions. Just keep trying. Try something else in the function. All right, it will work out. And if you have a single numerator or denominator, sorry, try dividing it out first. Usually your function will simplify, and then you're good to go. All right. You are doing questions 117 on page 354, section 5. All right, that's the end of this week's lessons. Good luck. Email me if you have any questions.